you going, guys? Curtis from Cutting Edge Engineering. So today we have an urgent job come in from one of our customers. We have a set of blade lift cylinder yokes in for repair. These are off a Caterpillar D11 Dozer, the biggest dozer Caterpillar make. So what the yokes do, they are mounted on the top of the nose cone. There is a hole there, or a socket, that these fit into, and then the blade lift cylinders are bolted onto these. So what the yokes do, they allow the blade lift cylinders to move left to right, and then they have another joint on them to allow the blade cylinders to move in and out from the machine while it is in operation. This part here goes into the nose cone of the dozer, and this slot in the back of the yoke, there is a key that goes in there to lock it from falling out. And this part here, which is commonly known as the fork, is where the blade lift cylinders bolt onto. These take all of the impact from the blade onto the machine while it's in. So these take all of the impacts that are transferred from the blade onto the machine. When you're talking a machine that size, the machine itself weighs over 100 tonne, and the blades with all of their wear packages and wear skins on them can weigh up to 18 tonne. So eventually these do wear out. There are bushes inside the nose cone that are supposed to wear out first, but steel on steel contact, sooner or later everything's going to wear. That's pretty much what's happened here, but the damage on these yokes is actually caused from the machine carrying its blade, not from the digging forces.
How can you tell that?
And I can tell that because the wear is on the top of the yokes. If it was on the bottom of the yokes, that would be done through standard operation, pushing material or pushing rock. But because it is on the top, it's because it's been carrying its blade. So the normal plan for repairing something like this would be to machine down the worn areas, build them up with an ER80S2 wire, and then send them out for heat treating. Unfortunately, we don't have time on our side for this job. We do have to get these completed today because they are booked to be on a truck tomorrow morning to be fitted back onto the machine. So we will be turning down the worn area, building it up with a metal on metal hard facing wire, and we'll be machining that back to spec. Generally, we would repair both of the wear surfaces, but because it's only the back side of the yoke that is actually damaged, we'll only be repairing that. The front side is still well within spec. It hasn't got any wear on it at all. So we're just gonna get this done and get our customer back to work.
So to set...
Oh, you son of a fucking whorebag. Oh, right in the leg.
A splinter in the leg.
That was sick. To start the repair on these, we will be setting these up in the lathe. In this case, we have to try and reach down past the bolt-on points and pick up on the center that was put in there from the factory. I do have a special mandrel that I have made for doing this exact repair, but I actually cut that up and used it for something else, so we're gonna have to make a new one. And to make this, I'm just gonna be using a scrap piece of cylinder rod from another job. So a mandrel is used for fixturing something into a machine. Basically, this is going to be a long series center. So we've got that set up in between our drive center and our live center. Because we're essentially driving off centers and I don't have a drive dog to suit this, I'm going to be using my green strapping tape to create friction between the yoke and the chuck. So I'll go over the top of it, back around, tie it off and go back the other way. That will essentially create a drive dog. There is a possibility it is going to slip, but I'm not going to be taking huge depths of cut on the job. Just take it off very slowly and it should be fine. And it will hopefully knock out some of the sound that these things make when you machine them. By sound, I mean a god-awful harmonic. Essentially, this is a big tuning fork. More speed under that. Change that up a bit, let's just not right. Righto, so that ceramic insert just isn't working for me. I'm going to change it out to a carbide insert and see if we have any luck with that. So this is a new insert to us. It is carbide, but it is designed for cutting induction hardened chrome bar and hard materials. So let's see how it goes. Righto, so that's the first one turned down. We ended up removing about 3 mil of material, so we'll get this one out of the lathe and get the other one set up. Righto, now we've got those turned down, we're going to take them over to the welding area and weld them up.
Does it matter that that spacer fell out?
I'm just going to go anyway.
Okay.
Very good. Righto guys, we've got this set up in the positioner now. What I need, so I've got this set up in our welding positioner. The filler wire I'm going to be using to refill the area I machined is going to be Stoody 965G hard facing wire. So it is a tubular wire. It's probably one of the only hard facing wires that you can still machine after it has been applied. We'll be backing that up with 9010 gas, which is Argo Shield metal core. And after we've machined it, we will end up with a surface hardness of 53 to 55 Rockwell, which will be perfect for a metal to metal wearing surface like this.
It was at this moment that he knew. He fucked up.
Oh, fuck me, motherfucker.
Might be a plumb hole to get started with. What I've done is I've put a weld at each end of the area that I will be repairing, and what I've done there is create a wall. So as the job heats up and the weld material becomes more molten and begins to flow a lot further across the job, I can then slowly bring it into the middle without overbuilding up the area and not worrying about material getting places it shouldn't be.
Oh my goodness. Hold on. Whoa. What was that? Hang on. You haven't finished opening the first one. What's that? Wait, what's in there? Really? Ooh, that's cool. I'm a great in TIG we trust. So, wow, holy, is that like a tigging kit?
Yeah, all different sorts of cups, gas lenses.
Cool.
Very cool. So a big thanks to Linton and Oz Welding Supplies for sending this TIG startup kit. Conversion charts.
A conversion chart.
That's awesome. How many do we get? A few.
Nice.
Put one there.
That's pretty good there.
Yeah, put one there. Put a couple in the workshop. So we can convert gibberish to English.
Bananas.
Bananas. So big thanks to Jim from Alabama for sending us these conversion charts. They're going to look good hung around the workshop. So we've got a couple more packages from America, so let's see what we got.
What is it? That must be who's made it. Handmade. Wow, holy, it's calligraphy done. Oh, it's printed like that. Cool. Bracelet from our collection. Oh, they've TIG welded it. Wow, that's bizarre. TIG welding thing and then...
Yeah.
Cool. Oh, wait, it's for me. This gift to Karen.
Oh.
Maybe I should open it. Ooh. Wow.
That's pretty
That's
cool.
so cool. It's kind of like the Sydney Harbour Bridge. Check me out.
Suave.
Very suave. Thank you very much, Adam and Catherine, for the very thoughtful handmade bracelet. I really appreciate the gift. Was that focused or like?
Oh, wow. Hope it's recording. Yeah, it says it is.
Oh, they own boarding kennels. Oh, they put lavender oil that they grow into dog products. Nice. I can smell it.
Oh, I thought that was for you. It's for dogs.
Oh, that's what they grow. That'll be strong.
It is. Shampoo.
Oh, very nice. It smells so pretty. Yum. So
a big thank you to John from, what is it? Big thank you to John for, where's he from? So a big thank you to John from Ohio Valley.
Oh my gosh.
Big thank you to John from Ohio Valley Lavender for sending Homeless some shampoo and some lavender ointment.
But where's the toy?
Didn't you get a toy? What's
He
this?
did. He
What's
wants
that?
more because there's boxes.
No, that's all you get.
You're so spoiled.
You are very spoiled. Righto guys, so I've got both of those
Yeah.
Yep. 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 Righto guys, so we've got our welds yoked. Oh, you're yoking. Oh, you ready?
Yeah.
Yeah, I guess I'm laughing. Righto guys, so we've got our yokes fully welded. They have cooled down. We're going to take them back over to the lathe so we can machine them to spec. Righto guys, so I've got this rough down. We just need to do our finishing cuts. I'm going to change from the carbide insert and go to a ceramic. No. So that is not working the way I thought or hoped it would. We're going to try something else. My fucking God. Right, so nothing seems to be working. We're still getting a weird harmonic and vibration coming back through the job. So I'm gonna go back to the old proven method with a WNGA ceramic insert, but I'm gonna angle the tool back a little bit using the tool post, slow down the feed rate, and see if I can get this to clean up and improve the surface finish. Give that a buff and that'll be spot on. Righto guys, so that is the first one done. Let's get this out of the lathe and get the other one set up. Righto, so that is our second yoke completed. Everything went really well. I'm really happy with how they turned out. Considering how urgent these are, we managed to get them done in the deadline, so we can save our customer any more downtime. We'll get these strapped down to a pallet and get them back to them. Thanks for watching. Considering how urgent these was, I don't know how to say that.
I don't know what you're trying to say either.
How'd you say that? And then there is a key that, for sending homeless, for sending homeless some shampoo and some, what is it?
No, excuse me. Hey, no, you turd.